Welcome back to part 6 of Unit 0 Science Practices. So let's jump right in. By the end of this video, you will be able to answer the following questions. What is the difference between descriptive and inferential statistics? How do measures of central tendency help us describe data? What can a distribution curve tell us about a data set? How can measures of variation summarize a data set? How does percentile rate help us describe data points? And then finally, how can we determine the extent to which observed differences can be generalized to other populations? The first thing we're going to start with are the types of statistical data analysis. So we have two different types. We have descriptive statistics and inferential statistics. In order to really tell the difference between these two, I just want you to look at the words themselves and look at the root words of each word. First, descriptive. What's the root word there? Describe. So descriptive statistics describe our data. When we are looking at a data set, it's just going to give us information of what does that data set look like. Inferential statistics, the root word of inferential is infer. So inferential statistics help us make inferences or draw conclusions about our data. Let's dive in a little bit further into descriptive statistics. So descriptive statistics can be separated into two categories. Our measures of central tendency, which are made up of our mean, median, and mode, and then our measures of variance, which is our range and standard deviation. Let's talk about the measures of central tendency first. First, we have our median. Our median is going to be the middle point of our data. Okay, so just like the median in a road, the median is the middle point of our data. So what we would do is we would put all of our numbers in numerical order, starting from the lowest up to the highest. Then we're going to count in until we find that middle number. That's going to be our median. The mode is the data point that is most frequent. Again, we're going to put all of our numbers in order and we're going to look at which number is represented most often. Finally, our mean is the average. So we are going to add up all of our numbers in our data set and we're going to divide by the number of data points in our set. So I want you to practice. Now, in AP Psych on the AP exam, you will not be allowed to use a calculator. So you will have to do it by hand. However, this particular data set, you will probably need a calculator. So go ahead and try it on your own. Okay, so let's look at our data set now that I have put them in order and we found our measures of central tendency. You can see that our median is the number 5. We're going to start at the outsides of our data points and we're going to work our way in until we get our middle number, which is 5. Our mode is the most frequent number that is represented. So we only have one 1, so it's not going to be that. We have 2 2s, 3 3s, 4 4s. We have 7 5s. We have 5 6s, 3 7s, 3 8s, 1 9, and 1 10. So 5 is represented the most. There's 7 of them. So our mode is going to be 5. Our mean then is going to be all of these numbers added up and divided by the number of data points. In this case, our sum would be 168, and there are 31 data points, and so we would take 168 divided by 31, which gives us 5.4. So again, our median, mode, and our means are measures of central tendency, and you will absolutely be asked to find these on an AP exam. The next type of descriptive statistics that we're going to talk about are our measures of variance. Our measures of variance are going to tell us how spread out our data set is. So are all of the numbers very, very close together, or are they super, super spread out? And so our two measures of variance are going to be range and standard deviation. Range is going to be how many numbers are there between our lowest and our highest number. Our standard deviation is going to be, on average, how far away is each number from our mean of 5.4? I want you to try and find our range and our standard deviation. You are welcome to use a calculator to find standard deviation because you will not be required to find this on your AP exam. Okay, so our range is 9. This is our highest number, 10, minus our lowest number, 1. So our range is 9. That means that our data is 9 points spread out. Our standard deviation is 2.14. While you won't actually have to calculate our range and our standard deviation on the AP exam, you will be required to understand what they mean. So a very small range or standard deviation means that our data points are very close together. You can see in this curve here. A thin curve means that all of our data points are very close to our average, in this case, 5.4. A high standard deviation, or a very spread out or wide or fat curve, means that our data points are extremely spread out and they are far away from our mean of 5.4. So in this case, our range of 9 and our standard deviation of 2.14 give us a fairly thin normal curve because our data points are not very spread out. Let's talk about the normal curve. So the normal curve is going to give us information about what our data looks like. A normal curve means that there are exactly the same amount of data points above the mean as there are below the mean, and they mirror each other. So what I did is I took all of the data that we had on the previous slide and I put it into a frequency graph. You can see that each data point is represented by one of these people here. And this shows us where all of our scores end up on a curve. For AP Psych, it is important for you to understand and know these percentages of how many of our data points are going to end up within 1, 2, and 3 standard deviations from the mean. So what do these percentages tell us? Well, if we look at our graph down here, we can see our mean, median, and mode for a normal curve are all going to be exactly the same. Then we can see that this first part of the normal curve is dark blue, and that shows us a percentage of 34.1. These percentages mean how many of our data points are within that standard deviation. So if we're looking at people, that would mean that 34.1% of people have a score between 0 and 1 standard deviations. In a normal curve, this is mirrored on the opposite side of the mean. So that means 34.1% of our data points are also between 0 and -1 standard deviation below the mean. As we go down, our percentages get smaller and smaller. If you add all of these numbers up above the mean, you can see that they will equal 50%. And that means that 50% of our scores are going to be above the mean and 50% of our scores are going to be below the mean. Now, most frequently in our data that we're going to be looking at and collecting in class, we're going to have what is called skewed distribution. It's going to mean that our numbers, our data points that we get is not going to be a perfectly normal curve. Most often in small data sets, we're going to have people who are on one extreme of the data or the other. So let's just take a test, for example. If you are going to take a test in math, there might be one person who is really, really fantastic at math and they get a 100%. There also might be someone who falls asleep during the test and gets a 1%. These are what we call outliers. The vast majority of people in the class are going to get around that 70 to 80% mark. But because we have people who are extreme on the 100% side and extreme on the 0% side, we're going to have what we call skewed distribution. And skewed distribution just means that our mean, our median, and our mode are not all of the same. And we have two different types of skewed distribution. We can have positively skewed data or we can have negatively skewed data. And the way I remember the difference between these is that the little tail here is pointing like an arrow toward a negative side of the number line, and our positively skewed tail here is like an arrow pointing toward the positive side of our number line. So let's look at what this might mean. So if we're taking our example of a math test and our average, our mean here is a 75%, a negatively skewed data set would be that vast majority of people, they are scoring above a 75%. However, we have one person who maybe got a 15%. This person's score is pulling the average down toward our negative side of the number line, right? So this would be a negatively skewed data set. If we're looking at the opposite type of a skewed distribution, the positively skewed, if we have that same math test and the average was a 75%, but the vast majority of people scored below a 75, that would mean that there's one person over here that scored a 100% that is pulling that mean toward that 100%. Some other things to think about when looking at data is that very often when we have extremely high or extremely low scores, they become more moderate the more and more we retest. So, for example, when I grade AP exams in the summer, people in the beginning of their grading will either score really, really easy and give all of the points, or score really, really hard and give no points. As we keep grading over and over, more and more tests, we start to regress towards the mean, which is about a 3.5. So we'll give 3.5 points out of 7, and all of our scoring tend to regress toward that, meaning that our skewed data tends to get closer and closer towards that mean the more and more we retest, or in this case would be scoring. Now, every once in a while, a data set will have two modes. This histogram looks like it has two humps. So our normal curve has one hump, and in this case, it has two humps. This is when we have a bimodal distribution. This is where there are two very distinct groups of participants or data points that almost form their own normal curves. Let's think about this in terms of a test. We've been talking about testing quite a bit. So a math test. This might be a group of kids with one teacher. This might be a group of kids with another. One group of kids does really, really well on the math test. That would be this high group here. The other group doesn't do so well. But within their groups, we have a normal distribution. Sometimes our data is going to work out this way, and we just have to be aware that it's called a bimodal distribution. Okay, the final thing we have to talk about with descriptive statistics is the idea of percentile rank. You see percentile rank a lot with growth curves. We see it with standardized testing. You saw it probably in your Iowa Basics or STAR reports or MAP tests as you grew up, right? So you are at the 80th percentile or 50th percentile. This is the percentile of individuals in the group that are at or below a particular value. So to put it in normal words, this means if you are at the 50th percentile, that means 50% of people have done worse than you. Okay? If you're at the 86th percentile, that means 86% of people have done worse than you. Okay, now let's move on to inferential statistics. Again, let's look at that root word. Inferential statistics make inferences or draw conclusions about our data. Statistical significance is whether or not the observed effect or the dependent variable in the study is likely due to chance or due to the independent variable. So the question that statistical significance is answering is, was the change in the dependent variable because of the independent variable or because of chance? Did the independent variable actually change the dependent variable? That is what we are answering when we are looking for statistical significance. Statistical significance is measured with our p-value. And our p-value can be anywhere from 0 to 1. In psychology, p being less than or equal to 0.05 is the accepted value for whether or not something is statistically significant. Now, I want you to look at these numbers just as numbers. If we take 0.05 and we change it into a percentage, what do we get? 5%. A p-value of 0.05 means that there is a 5% chance that something other than the independent variable caused the change in the dependent variable. And as psychologists, we accept that as okay. We say we're good with a 95% certainty that the independent variable is the reason for the change. We understand as psychologists that nothing is black and white. There can be no perfect things. So we'll accept 5% chance or less. Another inferential statistic that we look for is the effect size. The effect size is how meaningful the relationship between the variables or the difference between the group is. Meaning, does this actually tell us something about the population? Is the research finding practical? Does it tell us something about the real world? Or does it tell us just that this group of kids is special? We aren't going to spend a ton of time on effect size this year, but it is important for you to know.